Okay, I'm back, and now we want to talk about elements of a telescope. And the first topic is focusing mechanisms. So how is the light focused in a telescope? Well, there are two kinds of telescopes. You've got the refracting telescope and the reflecting telescope. So the original telescope that was made by Galileo, so if you recall, Galileo was the first scientist to actually make a telescope. So prior to this, the telescope was used for ships at sea, but it was never used for looking at the stars and the planets with. So Galileo was the first person to do that, and he made a very simple telescope using two converging lenses. And so you had one converging lens out here, which is going to be the objective, and then you got this converging lens here, which is up to your eye, so it's called the eyepiece. And then there's a distance between those two lenses, and that's going to be the length of your telescope. So that you're going to take the focal length of the objective lens and add it to the focal length of the eyepiece, and then that's going to be the distance between the two lenses. And then when you hold it up to your eye, that's going to give you the best possible image of an object. So that was the original telescope, just consisted of two lenses. Well, modern day telescopes, though, are going to be reflecting telescopes. And so here, this particular one is a Newtonian telescope in which the light is going down the barrel. It's being reflected off what kind of a mirror back here? Concave. And then the light goes to a secondary mirror where it's then reflected into your eye, where they have the eyepiece. So notice that the reflecting telescope has both a mirror and a lens in it. But that's what most modern telescopes are, is reflecting telescopes. Another thing about telescopes is how much light they can gather. And so this is the light gathering power, LGP, of a telescope. And it's proportional to the diameter, the opening to the telescope, squared. So bigger is normally better when it comes to telescopes. So the bigger the opening to your telescope, the more light it can gather, and that means that images of a star are going to be brighter because we can capture more photons of light that are coming from that star. Another thing is the magnification power, which, as you recall, I said wasn't that important when it comes to the kinds of telescopes that we use to look at stars. But if you're talking about a telescope that is used on Earth to look at something, yes, we are interested in the magnification power. And so what that is going to be is the focal length of the objective divided by the focal length of the eyepiece. So here is a sample question. An objective lens has a focal length of 8 centimeters. And then the eyepiece for this telescope has a focal length of 3 centimeters. Okay, if they're used in a telescope, what is the optimum distance between the two lenses? What is the magnification of this telescope? And then how large would a 5 centimeter object look when you look through the telescope at it? Okay, so we're first using equation 8.1. The distance between the two lenses is we're going to just add the two focal lengths. So 8 plus 3 makes 11 centimeters. So we're going to take the two lenses and put them 11 centimeters apart. That's going to be the length of our telescope. Then using equation 8.2, we're going to find out the magnification of the telescope. So that's going to be the focal length of the objective divided by the focal length of the eyepiece. And so that's going to be 2.7. Now notice it doesn't have any units, so it's just plain old 2.7. So an object that is originally 5 centimeters tall would be 2.7 times 5, or it would look like it's 13 centimeters tall when you look at it through the telescope. So is this a good telescope or a bad one? Well, it's a good one, okay, because it magnified the image. However, what you would find, though, is if you took that telescope in the sample question and you flip it around and you look in the other end, what do you think would happen to your magnification? Okay, this time you would flip it, and so it would be 1 divided by 2.7, and this would be a rotten telescope. It would make everything look smaller. Try it. So get some binoculars and look through the opposite end of the binoculars, and then everything looks small. If you look through them the right way, everything looks large. So you have to be careful about which focal lengths you choose to make your telescope with. So in our next segment, we're going to talk about what do we mean by diffraction. So I'll see you in just a moment.